Alright, so welcome back everybody. Today I've got a brand new coding tutorial video for you. I'm going to give you an introduction to blockchain development with Ethereum and the Solidity programming language. These are some of the most in-demand skills in tech right now, and I'm going to show you why in this video step by step, because I'm going to show you how to launch a live project out there into the wild on a blockchain in a matter of minutes, all from your web browser. So whether you're just checking out blockchain for the first time as a brand new coder with no experience, or you've got some experience in software development or blockchain already, then this video is for you, because we're going to use the latest versions of all the tools and technologies, and you're going to pick up some brand new tricks along the way. So before we get into that, if you're around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to become a blockchain master step by step from start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's go ahead and jump into this. What are we going to actually create today? Well, what I'm going to show you to do is actually launch your own cryptocurrency live on top of the Ethereum blockchain, how to hold it inside your Ethereum wallet like this. But then we're actually going to take it the next step, and we're going to put it on a cryptocurrency exchange. So in particular, we're going to use the decentralized cryptocurrency exchange Uniswap. This is one of the most powerful applications on top of the Ethereum platform today. It's one of the most used decentralized applications. And one of the cool things about Uniswap is you can list your token permissionlessly, okay? You don't have to ask anybody if you can list it. As long as you are able to access the blockchain directly, you can add your token to Uniswap and start trading it. So you can see lots of different cryptocurrencies on top of Ethereum. You can see lots of different cryptocurrencies on a website like CoinGecko.com that work like this. Basically, just go any of these coins and look at, maybe the DeFi coins, for example. A lot of these are Ethereum-based cryptocurrencies or ERC-20 tokens that run on top of the blockchain, because that's one of the beautiful things about Ethereum is it lets you create your own cryptocurrency without creating your own blockchain with smart contracts. That's exactly what we're going to do today. And we're going to show you how to create it and how to put it on an exchange like Uniswap. And another big benefit of doing this way with Solidity smart contracts is once you've created it, you can put it in multiple different places. So you can do it on Ethereum. You can do it on Binance Smart Chain if you want to trade on PancakeSwap. You can do it on Polygon Matic. You can put it on Optimism Layer 2. You can list it on SushiSwap, Balancer, whatever. All right, so who is this video for? Well, the short answer, it's for everybody. So anybody who, already has programming experience and wants to see how this specific skill works for blockchain, this is going to be a crash course on how to actually, launch something quickly on the blockchain with relatively little knowledge. Okay, that's the whole goal, is so that you can see how to do something pretty amazing on top of Ethereum. It's incredibly powerful. That's, potentially worth a lot of money, and, to get you started down that process. Okay. So if you have coding experience, you definitely can follow this video very fast. If you're brand new and you have zero coding experience, that's okay too, because we're going to learn this by doing. Okay. Some people ask me all the time, like, hey, if I want to learn blockchain, should I go learn web development first? Well, my answer is always no. You should start with the exact thing that you want to learn. And in this video, we're going to be very potent. We're going to be very focused. We're going to work on the Solidity programming language only. We're going to do everything in our browser, so you don't have to go through all these steps of setting things up in your computer. You're going to get a primer that shows you how the blockchain works. You'll get an introduction to the Solidity programming language. You'll learn everything as you go. And even if you know blockchain already, you're still probably going to get something out of this video, because we're going to use the latest version of the Solidity programming language, and you'll also pick up some pretty cool tips and tricks along the way. Okay, so here are our 3 main objectives that we're going to accomplish in this tutorial. We're going to create a cryptocurrency. Like I said, we're going to store it in a wallet, and then we're going to list it on an exchange. So we're going to go through these one by one, and you're going to get an introduction to everything you need to know to do this, okay? All the concepts and all the skills. So let's first start off with creating the cryptocurrency itself. So let's just kind of reason through this. What do you need in order to create a cryptocurrency on top of Ethereum? Well, like I said, one of the most beautiful things about Ethereum is you can launch your own cryptocurrency without creating your own blockchain with smart contracts. So we're going to create a smart contract to do that. So you're going to ask yourself, okay, so what do you need to create a smart contract? Well, you need a programming language, and we just need one programming language in this case, which is a really nice thing about this tutorial. Like I said, you can just do everything in your browser, but we're going to use the Solidity programming language. So this is the primary programming language used for creating smart contracts. This is the most in-demand programming language maybe on the face of the planet right now, because blockchain is such a hot skill. And, Solidity is the most potent skill if you're trying to, become a blockchain developer, the most critical thing to master, okay? So the good news is Solidity is a pretty, I would say, honestly, in the grand scheme of things, pretty beginner-friendly language. It reads a lot like Python, and JavaScript. And while there's going to be a lot of effort required to become a true Solidity master, you can still pick up the basics of the programming language pretty quickly, as you'll see in this tutorial. But if we're going to create an Ethereum token, we have to understand how it's going to work. So we need a basic set of guidelines and instructions for how this cryptocurrency should work in the first place. Okay. So the good news is we don't have to reinvent the wheel. Ethereum actually has a standard for doing this. It's called the ERC-20 token standard. And if you go look on a cryptocurrency website like this for checking prices, like CoinGecko, and you look at all these DeFi coins, most of these are ERC-20 tokens. So some really famous cryptocurrencies like Uniswap, the Uni token is an ERC-20 token. Chainlink is an ERC-20 token. These are just smart contract-based cryptocurrencies that run on top of Ethereum that all adhere to this standard. So what is the standard? Well, basically, it just describes how the token should work. So it determines what functions the smart contract actually has to be compliant with the ERC-20 standard. So it has to have some critical functions like a name. Every token must have a name. So you see, this right here. That's the Uniswap is the token name. The uni is the symbol. It must have a symbol. Okay. It must have these other functions that facilitate the behavior of the token, like the transfer function. Okay. This basically lets you send cryptocurrency from, one account to another. It must implement a transfer from function. So this tells you how the cryptocurrency can be traded on a decentralized exchange without your action on your part, I guess is what I'm trying to say. And then it also must implement very specific behavior inside these. And the last major thing is it must have very specific events. Okay, so events are basically a way to log a certain action on top of the blockchain. So a transfer event is logged anytime a token is sent. So basically whenever this function's called, it emits this transfer event. You're going to see all that as we go along. But the really important thing to understand here is this is a standard that we can adhere to, and we don't have to reinvent the wheel. So because we don't have to reinvent the wheel, we can use a library oftentimes to launch our own cryptocurrency really fast that is secure and audited. And that's what the Open Zeppelin library is for. Okay. So they have lots of different, contract patterns inside here. Like if you want to launch a cryptocurrency with ERC-20 tokens, you can do it quickly with Open Zeppelin. If you want to create your own non-fungible token or NFT, maybe crypto collectible, you can do it quickly with Open Zeppelin. But today we're actually going to use much simpler code that I've prepared ahead of time so that you don't have to reinvent the wheel and you can just create your own ERC-20 token. Now, you, of course, can just copy and paste this and, get up and running right away. But I'm going to show you how to, walk through some of it step by step. We're going to use this complete code solution. You can see it's just, quite a bit of comments in it. So probably it's only 30 lines of code in total. But we can build this out pretty quickly. And I'm going to show you how to do it in your browser. And you're getting a pretty good primer on how the Solidity programming language works. Now, you won't be a Solidity master after watching this tutorial, but that's not what it's for. The whole idea is to show you, how to create something really quickly and get you excited about what you're learning. And I have plenty of other step-by-step, much longer tutorials on this channel that show you how to build full stack applications on top of Ethereum. But this shows you how you can launch a crypto pretty fast, put it in your wallet and get it, trading on a decentralized cryptocurrency exchange in, less than an hour. All right. So now let's go ahead and get started coding. So head on over to remix.ethereum.org. So this is a website where you can create smart contracts with the Solidity programming language for Ethereum all inside your browser. Okay, so we don't have to set anything up on our computer today. All you need is to do everything on this website here. Okay, and you also need an Ethereum wallet installed. So you need Metamask. So if you don't have this installed, just look up on Google the Metamask Ethereum wallet. Okay, so this is basically turns your web browser into a blockchain browser, and it also lets you hold cryptocurrency inside your wallet, like Ether, for example. And you can also add Ethereum-based tokens, which we're going to do later in this tutorial. We're going to take the token that we created and actually add it to our Metamask wallet. And you're also going to need this wallet so that you can pay gas fees on top of Ethereum, because that's how it works. Anytime you create transactions, you deploy a smart contract to the network, or anytime, you trade a token on Uniswap or add your, cryptocurrency token that you created to Uniswap, you have to pay a gas fee to do that. And you'll need to sign these transactions with Metamask, but you'll see all that as we go. All right, so let's go ahead and get started. So inside of Remix, look over here on the side and you can see that you've got some folders, okay? So this is just what's called a directory in software development. It's just a list of folders that has a structure. And so you can click on the contracts folder into this directory. And this is where we'll actually create the smart contract for the token itself. All right. So inside of here, you can just click on this new file button. All right. This will create a new file. and you can just call it, token with a capital T, token.sol. That's how it works. Pretty easy. So we're going to create a contract inside of here called token. So that's the convention whenever you're writing a smart contract, is you do the file name the same name as the contract itself. And the convention here is to use a capital T for token as the file name because the contract name is capitalized. And then .sol is the file extension for Solidity smart contracts. So anytime you see .sol, that you know that there's a Solidity smart contract file inside of there. Okay. So it's pretty easy to get started. The first thing we want to do is actually declare the version of the Solidity programming language that we're using. You need to do that at the top of every single file. Basically, this just tells the Solidity compiler how to compile it. So basically, it needs to know what version of the programming language you're using, because inside of here, we're going to create human readable code with Solidity, but that has to get turned into machine readable code when it gets compiled. And so you have to tell it the compiler version. So we'll see that here in a minute. But you do like this. So pragma, Solidity, and then we're going to say version 0.8.6. I'm actually bump this up so you can see it better. So that's how you do it. Pragma, Solidity, version 0.8.6. And you use a semicolon after every line like this. All right. And the next thing we do is we just declare the contract. So we do that with the contract keyword inside Solidity. So you say contract, and then we do capital T, token. All right. And then we do curly braces. And then inside these curly braces is where all the code for the actual smart contract will live. Okay, so this is like a shell that you can think about. This is where all the code for the contract goes, and then anything on these new lines inside these curly braces is where the smart contract code will go. So every token for Ethereum has to have a name. Okay, just like we've seen here. These tokens all have names, like the Uniswap token. All right. They have symbols, et cetera, et cetera. And so what we can do with the first step is actually just create the name for our token. So how do we do that? Well, inside the smart contract, we can just store it in a variable. Okay. Pretty easy. Just like this. So we say string public name, and we're just going to call it my token. So let me break this down a little more. So this is a variable inside the smart contract, but is a special kind of variable called a state variable. All right. So there are different types of variables inside Solidity. We'll see that more here in a minute. But basically, this variable, it just stores dynamic information. In this case, it's going to be static because we're just assigning it here once. But basically, this is where the name of the token goes. It's a string type, which basically means this data type right here. So a string is anything that's contained inside these quotation marks. So that's different from like, an integer, which might be one. One's an integer, but the phrase "my token" inside quotation marks is a string. So there are different data types inside Solidity. A string is an example. An unsigned integer, uint is an example. There's struct. There's all kinds of stuff, but this is a string, which is important to understand. And the last thing is it's public, which basically means that we can read this variable outside the smart contract. So when you put this token inside your cryptocurrency wallet, it needs to be able to read the variable called name, and we declare it public so that your cryptocurrency wallet can do that, okay? And also other exchanges, et cetera, right? So let's go ahead and go through the next step, which is actually just compiling the contract and testing it out so you can see how this name variable works. This is going to be a test to make sure that everything's set up properly and it's working. We'll continue to iterate on this smart contract here in a minute. But you can just go in your browser here over to this button right here. This is deploy and run transactions. Okay, so if you don't see this, you might have to go down to the plugins tab and search for deploy and run transactions. Okay, so if I'm ever doing a step over here and you don't see the link on the sidebar, just click the plugins button here, and you can search for whatever the plugin name that I'm using is. Okay, so here it's deploy run transactions. You can see the plugin name at the top. So if you don't see it, you just search for it there. So anyway, so what we're going to do is go ahead and compile the smart contract down and put it on a test blockchain. So like I was saying a second ago, whenever you deploy a smart contract, you have to compile it. So what does that mean? Well, here we have human readable code. This basically means that you or I can read this. It reads somewhat like English, right? There's actually some English words in here, but a computer doesn't understand this code. So whenever we want a computer to understand it, we compile it. We take it down and convert it from this human readable code into machine readable code called bytecode that's actually going to get run on the blockchain. And it gets run on top of the Ethereum virtual machine, that computer process that interprets smart contract code and actually runs like on an Ethereum node. So anytime you're interacting with the blockchain, of course, it's a peer-to-peer network of nodes that all talk to one another. And each one of those nodes that's executing smart contracts transactions is using the Ethereum virtual machine. So we have to take this code and compile it down into a way that the EVM, that's a short for Ethereum virtual machine, understands. We can actually, before we deploy and run transactions, we go to this compilation step here. So you can see the Solidity icon with the refresh wheel. We can choose a compiler type. So basically, we want to go up to 0.8.6. All right, that's the latest version. That's the version we have here in our file. And we click compile, and it works. So we have a warning here. It says SPDX license identifier not provided in source file. So you're supposed to provide the license at the top. So you can do that like this. All right, that's actually contained in the source code that I'll put a link to in the description below. I've got the final code solution. Like, you could just copy and paste this whole thing and skip this step if you wanted to, but I'm just going to give you a quick introduction to how this works if you're brand new to coding and want to see this. Okay, we do that, click compile, it works, no more warnings, and now we can actually deploy it. So for this step, we're not really going to use Metamask, okay? We're just going to do everything inside of Remix. So Remix has a test blockchain built into it and some test accounts. You see the environment, right? We're just going to use this JavaScript virtual machine. So it's a JavaScript version of Ethereum that's just running in your browser. Okay, it's not a real blockchain. You're not using MetaMask. You can see that you have all these accounts here with 100 fake Ether. You can act as any one of these accounts. But yeah, I'm just going to show you this quickly so that you can see how the token development lifecycle works. So let's just click the token as the contract we want to deploy. Click deploy, and then boom, there you go. You can see it listed in your sidebar here. You can see the address for the token right here. So the address is the location of the token on the blockchain. Now it's in memory. That's what it's saying here. Basically, it just lives in your browser. It's not actually on a blockchain yet. But now you can see the functions that the token has. Okay, so you can see the name function right here, and you can click on this, and you can see it returns a string, and it's my token. All right, so that's the variable that we set here. All right, so you could change this. You could call it my great token, and change it, and watch your changes happen in real time. So if you're going to change the code, then you have to go over here and recompile it. All right, and then deploy it again. All right, and then you'll see a new copy of your token listed here, and you can read it, and you can see the variable name has changed. So that's one important thing to understand about Ethereum smart contracts is, in and of themselves, they can't really change. So if you make a code change, then you have to redeploy a copy of your smart contract to the network. You have to go through the compilation step again. You have to deploy it again because they're immutable. They can't change. You're supposed to be able to just trust that it stays the same. Now, there are smart contracts that can change live on the network, but that's a little bit of a different story for a different day. But from your perspective as a beginner just going through this, the actual contracts that you'll write, these less sophisticated ones, don't really change. So anytime you make changes, you have to go through that process. All right, so next I'm just going to go ahead and paste in a few more settings for the token that are going to show you how it works. So basically, we're going to add some more variables. We're going to add a variable for the symbol. Okay, so this is the symbol that you'll see on a cryptocurrency exchange, like the Uniswap token. The symbol is Uni. So we're just going to call it MTK will be our symbol. The next thing is you need to set the decimal places for the token. So what does this mean? You can think of decimals like this way. So think about US dollar currency. So dollars are represented like this. If you have $1, you only have 100 pennies that make up a dollar. You can't really subdivide a dollar any further than that at the actual currency level. Okay, so basically a dollar has 2 decimal places after it because 100 pennies make up a dollar, and there's nothing smaller than a penny. So with tokens, basically you want to determine how many zeros are after the decimal place. That's what the decimals variable is. So basically, with tokens, the convention is to do 18 decimal places because that's how Ether works. So Ether is the native cryptocurrency of the Ethereum blockchain. It works different from tokens, but Ether is divisible by 18 decimal places. And so that's the convention for tokens. So basically, your token's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros after the decimal place. Okay, so that's what 18 is. And then lastly, we want to do a total supply of 1 million. All right, so how we do that is basically you say 1 million, so 1, 2, 3, 4, 5, 6, but then you have to do 18 decimal places after it to actually represent the total amount of tokens, because it has 18 zeros after the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Of course, this is not dollars. So we put that here. All right. So the reason we do that is because your token, Solidity does not support decimals. All right. Every time you store numbers on the blockchain, you have to do it with integers. Okay. So that's what this data type here is, a uint. So a uint stands for unsigned integer. So it's an integer that does not have a sign. It's unsigned. So a sign would be negative. So it can't be negative. So a signed integer might be negative, 1 million. But an unsigned integer would just be like a million with no sign. And of course, these variables are also public. All right. So now, that's how we would do all the configuration for the tokens. We can just go through the, compile and deploy. All right. You can see it here. Decimals, name, symbol, total supply. And total supply is just the actual amount of cryptocurrency that's, available in the entire, for the entire cryptocurrency game. All right, so next I'm going to show you how to actually make these settings dynamic. So what do I mean by that? Like how you can customize them however you want to, so that it's not just, hard-coded into the contract. So I'm going to introduce you to something called the constructor function for Solidity. So this is a function. So if you're new to programming, basically a function is just like a command that you can run inside the smart contract that actually does something. And then you can put a bunch of information or steps inside the function that get executed whenever it's called. So you call a function that, writes some information, and you do steps inside of it. So we can use a special function called the constructor function inside Solidity. And what this does is actually execute some code whenever the smart contract is created or put on the blockchain itself. And we can pass some arguments into this function, these special variables right here, like this. We can just tell it what the name is going to be, what the symbol is going to be, what the decimals and what the total supply are going to be. And whenever we do that, we can take these local variables that we pass in, all right, these name, symbol, decimals, and we can assign them to the state variables that are declared here inside our smart contract. So instead of, writing the name here, we can just, pass it into the constructor function whenever we create the contract. Same thing for symbol. We can just, write it that way. We can take out the decimals and total supply, and we can set all this stuff whenever the contract is created. So that's what the constructor function does, and that's how we can do it right now. So I'll just show you how to do it. Go to compile. All right. Then go to deploy. And then now you can see this deploy has, let me just kill these first. This deploy has a drop-down menu. Click the caret. And you see the name is, my token. Symbol MTK. Decimals 18. And then 1 million. 1. And then 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. And then click transact. And there you go. Boom. Token, decimals, name, symbol, and total supply. Perfect. So now I want to show you how tokens actually track people's balances. So what do I mean by that? Well, the smart contract, one of the most important things that it does, keeps track of who owns how many tokens. So if you were to look at like, this Uniswap token, for example, you can click on it. You can look at the actual contract itself. Let's just look at it on Etherscan. So the Etherscan is a website where you can inspect all the contracts and transactions on top of Ethereum. And if you look at the actual Uniswap token itself, let's just find it. You can look at the holders, and you can see like, some of the top addresses hold like 86 million Uni tokens. All right. These are contracts, but this one's not a contract. So 24 million tokens about. So how does the cryptocurrency know that this particular account holds 24 million tokens? Well, it does it with something special inside the code. We have something called a mapping. Okay. So what is a mapping? Basically, it's a mapping that shows you, it keeps track of, it lets you store information based on key values. What do I mean by that? Basically, it takes a key, which is sort of like an ID for a database. In this case, the key is an address. It says mapping address right here. All right. You pass in an address and it returns a value. So you can put in an address for a token holder in this case, and it returns an unsigned integer, this UNT256, that corresponds to the number of tokens that that person holds. And now it's important to understand that these keys or these addresses are unique. So only one address will ever, it's deterministic. If I pass in an address, it's always going to return the same value. So in this case, basically, if I put this person's address in that we saw right here, it's going to return the same value every time. So key value, key value. All right. So we can see that inside here. So we can give this mapping a name. We can call it balance of, and we can call it public. All right. So we can access it outside of the smart contract, and Solidity is actually going to give us a special function for free, just like we did with these variables over here, that will actually let us query the balance of a particular account whenever we apply this public label. This mapping will basically be a variable, it'll be public, and it'll have this mapping structure associated with it. Okay, and that's how we keep track of who owns how many tokens. Now, what we're going to do is actually assign all the tokens created whenever we deploy the smart contract to the person who created it, or the deployer. In this case, it's going to be our Ethereum account that we're deploying to the blockchain with, this one right here. Okay, so we can do that like this. Basically, whenever the smart contract gets put on the blockchain, we can just say balance of message sender equals total supply. So what does that mean? Well, basically, you take the balance of mapping here, and this step in the function actually adds a new value based on this key. So we could just say, balance of, we could hard code our address in here, but instead we're going to use a special variable inside Solidity called message sender. So msg.sender. This is a global variable, and it has a special sender value that corresponds to the person who's calling the function. All right. In this case, the constructor function is being called by the person deploying the smart contract. So what we're saying here is the balance of the person who's deploying the smart contract, basically assign all the tokens to their account. So we pass in the total supply here. We say take the total supply and assign it to this person, the person who's deploying the contract. So whenever we create the tokens, we will basically own all of them. But whenever we do that, we can, of course, supply liquidity on Uniswap and let other people start buying them, just like, an initial DEX offering. Okay. That's how that works. So we can see this in real time. We can go to compile, and then we can click deploy. Well, first of all, we need to kill this. And we add some settings here. Name, my token, symbol, MTK, decimals, 18, total supply, 1, 1, 2, 3, 4, 5, 6, and then 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Click transact. And now we can paste in the balance of the account up here. Basically just copy it, paste it inside of here. All right. And then click call. And there you go. You can see all the tokens have been assigned to us. All right. So now what I want to do is actually show you how to code the transfer function. So what does that mean? Well, basically, this mapping is the balance of. This tells us how many tokens each person has, but now it's actually code out the behavior that lets people send tokens from one account to another. Okay, so that's what this transfer function is called. So we can just say function, all right, transfer, and basically we can implement all the code inside of here that will perform each step that takes tokens out of somebody's account and puts it in somebody else's account. Okay. So if we're going to do this, we need two pieces of information. We need to address who it's going to. So we say address to. So that's just a variable, an argument that we pass into the function. We need to know how much cryptocurrency that they're sending. So we can say value. And that's a data type of UNT256. All right. And then we also want this variable to be external. And we want to return a Boolean value because it's part of the ERC-20 spec. So we just say external returns a Boolean type of success variable name. Okay. So inside of here, all we really have to do is essentially move tokens from one account to another. So we can just do it like this. We can just query the balance of the account that we're debiting tokens from. We say balance of. All right. And then we say, from. So basically from will be the account who's sending it. Basically, in this case, it's going to be message sender, like we saw a second ago. All right. And then we'll say equals balance of, all right, from, and then we'll take away the value. All right. So basically this value that's being passed in, we're going to debit it from this account, and then we're going to credit it to the other account. All right. Boom. It's really that easy. Like that's the core of the transfer function is we say, take tokens out of my account, the person who's calling this function. And then that's how you do it. Take them out and then add them to the other person's account who we're passing in here, this, 2 right here. Okay. So that's really all you need for the core functionality of the transfer function. Now, it becomes a little more sophisticated than that because the ERC-20 standard requires us to actually log events every time this is created. or every time a transfer event happens. So we're going to create something called an event, called a transfer event, like this. So below this mapping, we're going to paste this in. This is how you declare a transfer event. So you say event transfer, pass in the address, index, here's the from account it's coming from, and then here's the address it's going to, and then here's the value. That's how you define an event with the event keyword, and you give it the name, and then you pass in the arguments for the event, okay? And then finally, you can just emit the event inside of here, and just say emit transfer, and then say, from, to, and then value, okay? And so the last thing we want to do is actually add some conditions to this function to make sure that it works like we intend it to, and it actually has some safeguards around it. So basically what we want to do is make sure that the person transferring tokens actually has tokens in their account before they can do that. Because you don't want people just sending tokens that they don't have, right? So Solidity has something called a require function. And anything we pass inside of here, if it evaluates a true, the function can continue execution. But if it evaluates a false, then it'll just stop. It'll just revert, and we won't actually be able to do this stuff. So inside this require function, we want to make sure that the person has enough tokens in their account to do this. So basically, we just say require balance of message sender is greater than or equal to the value that's getting passed in. So basically, we just want to say like, hey, do you have enough tokens in your account before you try to do this? All right. So that's how it works. All right. The last thing we want to do is actually return true here. Because per the ERC-20 spec, we need to return a Boolean variable of success. And if this function works, then we need to just return true. All right. So now what we can do is actually see this in real time. We can just kill this. We can go to the compiler, click compile. All right. Actually, we have a little problem here. Let me just fix this. Basically, we need to change this from, to msg.sender. And then also this from here to message.sender. We'll change it back to from here in a minute. You'll see how it works. Compile. Now it works. And you can go here and you can click contract token, click deploy, put in the information, my token, symbol MTK, decimals 18, 2, 3, 4, 5, 6, and then 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Click transact. And now we can actually execute the transfer function by going up to the top and clicking on the accounts, finding the second account, and clicking copying. Click copy. All right. And then switch back to the first account. But then you want to take the second account and paste it here in this transfer function. Click the drop down, and then paste in the to account, paste it in here, and then put in some amount of tokens. I just put in 100 tokens, so 100 followed by 18 decimal places. Click transact, and then there you go. So now we can query the balance of that same account we just sent the tokens to, and now you should see the account balance here. And then you can also look at the balance from the first account in the list, and then add it to the balance of. Let me just do this real quick. Hold on. Paste it in here, query it, and click call, and you can see that it's gone down. So we successfully implemented the transfer logic. So that's a lot of the major functionality for the ERC-20 token. Really what I want to show you here is how to work with variables, how to work with mappings, how to work with events, how to work with constructor, how to work with functions. The next two things I'm going to do here is I'm going to finish off this smart contract with some faster kind of copy and paste coding here, because I don't want to spend all day just building out this token. There's only a little bit left, to tell you the truth, but I wanted to show you how to, use each part of this token. So what we're going to do is actually just go ahead and paste in the final code solution for the token, and I'm going to explain how the other parts work. Okay. So I'm just literally going to go to the GitHub here and then copy it, and then put in the rest here. If you want a full tutorial on how to code a ERC-20 token step by step, we've got some other tutorials on this channel. We, of course, do that also inside the Blockchain Bootcamp with, an entire truffle project with tests and everything. But now what we can see is we have the entire token with code comments and everything. We have the variables up top. We have an address for the balance. Okay. We have the transfer function that we saw here. We have the constructor like we saw here. Here's the transfer function, but it's actually been broken out into a new function. So you can see it here. So why is that? Well, the next function is called transfer from. So what does that do? Well, for ERC-20 tokens, whenever we're calling the transfer function, basically we're spending tokens ourselves. So if you're in your wallet and you send a token around yourself, you're calling the transfer function. But if you list a token on an exchange, your tokens get sold for you by the actual exchange itself, then it uses the transfer from function. So basically this is saying who's the account it's coming from and who's it going to. And you can see it works basically just like the transfer function, because we can see that it's actually using the internals of the transfer function right here. So I've taken it out and put it in its own function up here, and you can see it's reused, right, with transfer, and then it's also used inside this transfer from function. So the last thing is whenever you do transfer from, an app needs permission to do that. And so that's what this approve function does. So approve basically says, I'm going to let a certain account spend my cryptocurrency for me. So you can specify what account that is. That's the spender address here. And then there's the value, which is the amount of cryptocurrency that you're letting them spend. So if you go swap a token on Uniswap, for example, you'll go up here, you'll say, I want to swap, some token, let's say the Aave token for ETH. You're going to have two steps. You're going to have to approve the token so that Uniswap can swap it for you. And then you're going to have to do the actual swap, because whenever you do this swap, Uniswap takes the tokens out of your wallet and does the exchange for you. And so it uses this transfer from function here in that process. But the first step in the process is you approving the tokens for them to do that. So that's why you put in the spender. In this case, would be the Uniswap address, and the value would be the amount of tokens that they want to swap for you. So what this function does is it adds Uniswap to your list of approvals, or your allowance. So you can see this allowance mapping inside of here. This basically keeps track of your account and then all of the addresses that are allowed to spend tokens on your behalf, and then the amount. And then whenever you approve tokens, it has to emit an approval event, just like the transfer event. That's the complete token code. So we can just, check that all this works. Again, the final code solutions in that GitHub repo that I'll link to down below. You can click compile, compile token, still works. You can deploy it to a test blockchain. You can, do the settings. You can call it whatever you want to. My token, MTK, 18 decimals, then we can do a million tokens. 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Click transact, and it all still works. All right, so now that we've created the cryptocurrency, let's actually launch it. Let's put it on a real blockchain and list it on a decentralized exchange so that other people can buy it. We're going to do this on a test network, okay? So there's lots of reasons. So basically, Ethereum supports multiple environments. It supports the main Ethereum network that you might know and use today if you're actually using Uniswap for real. And the steps I'm about to show you will work on the Ethereum mainnet for sure. But we're going to use a test network. So this is a different environment where basically you can, test your applications out. You don't have to risk any real money. So we're going to use Ether on the test network, but it's just fake Ether. It's not actually worth anything in the real world. And then also, if you're worried about launching a cryptocurrency out in the world and then doing something illegal, then I don't think you have anything to worry about by doing it on a test network, because you're not doing anything with real money. Okay. So that's the whole point here. We're going to use a test network for those reasons. So we're going to use something called the Kovan test network. So inside MetaMask, click your network selector at the top and click on Kovan. All right, Kovan test network. And now in order to do this, we need some Ether in our wallet to pay for gas fees, to list this token on Uniswap, and all that type of stuff. So we can get some Ether for free by going to link faucet here. See this in your documentation and the instructions here. So you can copy your address. You can paste it in here, click you're not a robot, and then send me test ETH. All right. So whenever you do this, you should see it pop up in your MetaMask here. So boom, there we go. Got 0.1 ETH. And so now we can actually put the cryptocurrency live on the blockchain. So we'll go back to Remix here. We've already, compiled the contract. We can go to the deployment step. All right. And here's where we're going to actually select the Kovan test network. So instead of doing this JavaScript virtual machine, we're going to select injected Web3, which is going to be our MetaMask account here. All right, you can see it. You might have to connect your MetaMask here. It might ask you to connect, but I've already done it. And then so we can see our account. So what we're going to do is deploy the token to the network, and we have to pay gas fees in order to do this. So you're going to see a MetaMask confirmation pop up, because whenever you put a smart contract in the blockchain, you have to pay a gas fee that's denominated in Ether, okay? So basically, you're creating a transaction, you're changing the blockchain state, and anytime you put new information on the blockchain, you're essentially writing new information to it, and you have to pay to do that. So that prevents spam on the network, and so you have to pay. Let's click, let's see here, deploy, Kovan, fill out your information, my token, MTK, 18 decimals, total supply, click transact, and then he'll see your confirmation pop up. You'll sign it, click confirm. You'll see the creation of tokens pending, and there you go, it worked. You can see the contract address here. Click this, and you can also click on debug, and you can see, I can't remember, your Remix doesn't actually put a link here, but you can go to your browser here. You can go to kovan.etherscan.io. All right, I'm doing it off screen. And you can see the blockchain explorer for the actual Kovan test network. So this is kovan.etherscan.io. You can paste in your contract address here. And then boom, there we go. There's the contract that we created. You can see the transaction hash that was created a few seconds ago. You can actually click on the contract. You can do verify and publish. You can click compiler type, Solidity single file, 0.8.6. You can just do no license if you want to, or any license you want to. You can take the contract code, go from Remix, copy it, go to Kovan, enter the contract source code, and then I'm not a robot. Click verify and publish. And let's see here if it works. This might take a second. And then boom, there we go. So now you can actually see the contract was verified. So this is pretty standard practice on Etherscan, if you're launching your own project, is to verify your smart contracts so that people can see how they work. And now you can see the contract name, token. You can see all the source code saved in it on Etherscan. You can see the smart contract ABI, the contract creation code, all that type of stuff. All right. And then also one big benefit is it gives you this interface to read from your smart contract and write to it. So you can see, how many tokens do I have? You can go to your Metamask here, copy your address, paste it into the balance of, and then click query. And you can see you have all the tokens. All right. Now I'm going to show you how to actually add this token to your Ethereum wallet in Metamask. So you can see how many tokens you actually have. You just copy the contract address. All right. Go to Metamask and just click on assets and then add token and then paste in the contract address and it'll auto-populate the symbol and the decimals. Click next. And there you go. All right. And now you can send these around to whoever you want to. You could take some arbitrary address, right? Like you just find some other address in MetaMask. You could just go to, some address here. You could just, I don't know, just click on this miner. And we can send them some of our tokens. Just copy it. And then go to MetaMask. And now you can send your tokens around. You can just click send. And then actually paste in an address here. Let's just see, copy it. All right, and then just say send the tokens, swap from Ether to tokens, and say we just want to send them one token. So now inside MetaMask, you don't have to do the crazy stuff. You can actually do decimal places, but we want to send them one token. We can just do that. Click next, and then boom, there we go. You'll see it populate whenever it's finished. All right. So we've completed several of the objectives so far. So we can just see on our whiteboard here, we've completed the first objective of creating the crypto. Now we have actually put it on a blockchain and we have stored it in our wallet. Okay. So now we want to do this last step of actually listing on an exchange. So we're going to do this with Uniswap. All right. So in order to list it on Uniswap, we're going to use something called a liquidity pool. So what does that mean? Well, basically Uniswap uses something called an automated market maker. So whenever you go to Uniswap, you just tell it which token you have and which token you want to swap it for. And it just does the magic behind the scenes. There's no order book. There's no candlestick chart. There's nothing like that you would see in a traditional exchange that would have, traditional market makers. This has something called an automated market maker on the back end. So how that works is basically you provide liquidity to Uniswap. So you are the market maker and other people who hold this token can also be market makers, but you're the first one. You have to provide funds to this liquidity pool in order that other people can buy it. And so how it works is you create a trading pair. So in this case, we're going to take the two cryptocurrencies that we have in our wallet, our token, my token MTK, and then also Ether, which we hold in our wallet. And we're going to take equal weightings of my token and Ether that will actually set the initial price for the token whenever we deploy it or we put it in a liquidity pool. So I'll show you how to do that. Basically, you go to Uniswap. All right, so you go to Uniswap here. Make sure that you select your account and make sure you select the Kovan test network, okay? And you'll see that you're created here. So you can look at the steps inside your GitHub repository. Basically, you click on the pool tab, which is here. All right, so we're on the swap tab. We want to go over to pool. And then you go to, create new pool, new position here. All right. So for the pair, we want to leave ETH selected. Okay. And then you want to actually, select the token. So what you want to do here is take your token that you deployed to Etherscan. Actually, let's just find it. Or you can go back to Remix and find it here. Let's go to Remix, find your token address, copy it, go back to Uniswap, and then paste it in. All right. And then you import my token. Okay. And basically on the same page, you want to click Add Liquidity, and then do like this. So it doesn't appear the active token list. Make sure you want to list a token you want to trade. Yeah, that's okay. You want to import it. And so we want to set a fee. So this is probably the best for most pairs. So we're going to click 0.3%. Okay. So for initializing pool, we want to set the starting price for the token. Basically, the price is going to be reflected in ETH. So about the time I record this video, ETH is about $2,500. So basically, you could just say that $2,500 worth of ETH buys, you know, like, I don't know, 1,000 tokens. 1, 2, 3. If you give it 1 ETH, it'll give you 1,000 tokens. Okay. Minimum price of how many tokens per ETH? Let's just say, you know, 500, and then max 2,000. All right. And so now we can say how much ETH we want to deposit. Well, we don't have very much ETH in our wallet, so we can just do a minimal liquidity. If you want to have a lot more liquidity, you need a lot more ETH in your wallet. So for this demo purposes, you won't be able to buy many tokens on the grand scheme of things. But if you have a lot more Ether, you can increase this. But I'm just going to like 0.01 ETH. And that means we're going to deposit an equal share of only 9 tokens. So now we'll click Approve. All right, click Confirm. This is the approval step we talked about. I click Preview, and then you can see all the settings here. It's in range. Click Add. All right, Confirm. And then there we go. I'll give you an Explorer. And so now we have completed this last step of actually listing the token on the exchange. So let's demo it. Let's actually see. Let's see it work in real time. So the transaction's been submitted. You can go back to Uniswap, and now anybody can, you know, buy your token. A good test of this will be actually using a different account, sending an Ether, and all that type of stuff. But for now, we're just going to use the same account. We're going to click on the token that we have, which is ETH. We got ETH in our wallet here. And we want to buy my token. So we'll just paste in the contract address for my token here. All right. And then we'll click MTK. Let's just paste in the right one. I deployed this before, so let's just copy it. Go back to Uniswap, make sure I got the right one. Paste in the address. All right, click on that one. All right, so enter in, let's say 0.01 Ether. Let's say 0.0001 Ether. Actually, let's just, hold on. Sorry, this one. All right, and that will give us a new token. Click Swap. Confirm Swap. Confirm. And you can see it has a nice special link to add the token to your wallet if it's not already. And then you can see the transaction. Wait for it to finish. Sometimes it takes a second on the test network. All right, boom, there we go. So we've transferred tokens from our wallet like this. Perfect. So now you've accomplished every single one of these steps. You know, you created a smart contract, you've created a cryptocurrency, you've put it out there live on the blockchain. You've got an introduction to the coding on this. You have, you know, listed it on an exchange. You can actually trade it live right now. So that's your introduction to Ethereum programming with smart contracts. This is how you can implement something really powerful in under an hour. Like you can launch a cryptocurrency, put it on the network, get people live trading it really fast. So we've covered a lot today in a short amount of time. If you want to get your hands dirty and you continue on beyond this, we have lots of tutorials on my YouTube homepage. You can go there, like full-on Udemy courses, but they're totally free. So taking you to the next step, which is basically building a full-stack blockchain application. Maybe you want to build a, you know, simple token exchange. You can do that. You want to build a DeFi project. You can do that. You've got the, you know, front ends with JavaScript. You got the back ends with Solidity smart contracts and Truffle. You'll figure out how to write, you know, tests for them. And if you like those courses and you want to take the next step, then I can show you how to become a blockchain master, like a real professional level blockchain developer over at dappuniversity.com/bootcamp. All right. You don't have to be an expert to get started today. I've helped people with zero coding experience become real world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.